Good morning and welcome to example 15, which says that the function fx is defined by the root of x minus 2, and x is a real number and x is greater than or equals to 2. Part A, state the range of fx. The range of fx, part A. The range of fx is just the solution after substituting the domain of x. So we have the least value of the domain of x to be 2. So if we happen to substitute 2 here, then we are going to get the range of fx. We're going to get the range of fx to be 2 minus 2, 0, and the root of 2. Of course, the range is now the value of y, because this is the value of x. Remember, this is the independent variable and y is the dependent variable, which is also going to be a real number, and y is going to be greater than or equals to 0. 0 in the sense that when x is 2 here minus 2, the root, we get 0, and the root of 0 is 0. If x, for that matter, happens to be something different, like let's say 3 minus 2, we get 1, and of course the root of 1 is 1. So this is the range of that particular function. Part B, we are supposed to find the inverse function and state its domain and its range. The inverse function, as we have understood in the previous example, we rewrite that one in terms of y is equals to the root of x minus 2. We need first of all to interchange the variables. That means y becomes x and x becomes y, and then try to make the new y the subject of the formula. We can only do so by first of all squaring both sides. We have x squared is equals to y minus 2. Remember, when you square a root, then you get the original number free from the root. Now, making y the subject, you're going to have y is equals to x squared plus 2. And this happens to be now the inverse function of x squared plus 2. We are also supposed to state its domain. The domain of the inverse function happens to be the range of the original function. So we can easily talk about this range of the original function to be the domain of the inverse function. So we don't look for it far from this value. So the domain of the inverse function is of course, because we are talking about a variable x, which is a real number, and x is greater than or equals to 0. Remember, the range of the original function happens to be the domain of the inverse function. What about the range? Now, the range of the inverse function, or the range of any function, the range of the inverse function is now the value of y, where y is a real number, and it will be determined by its domain. So the least value of x in the inverse function is 0. So we need to substitute x being 0 here, and of course we get 0 plus 2 is equals to 2. And that now becomes the range of the inverse function, meaning that beyond 2 it can be anything. For example, if we put x to be 1, 1 squared is 1 plus 2, then the inverse function gives us a 3. So we are well within our range. But it is part C that we must look at it a bit more seriously, that we're supposed to sketch y is equals to fx and y is equals to f prime x, and the line y is equals to x. At that point, we must remember that y is equals to fx is given by x minus 2, and y is equals to f prime x is given by x squared plus 2. We must not forget this, because this is now where our graph is supposed to be. This is now what you're supposed to sketch. If we start by the function of x, we must consider the domain. The domain x is greater than or equals to 2. So when we have 1 there, 2, 3, 4, 5, 6, moving forward we have 1, 2, 3, 4, 5, 6. Moving forward, and you have 1, 2, 3, 4, 5, 6, 7. When x is supposed to be 2, because this is the least value that x can have, then we are supposed to have 2 minus 2, which is 0, and the root of 0 is 0. You can see that being the very least range. So when x is 2, y is 0. When x is 3 for that matter, 3 minus 2 is 1. The root of 1 is 1. So somewhere there. When x is supposed to be, let's say, 6, 6 minus 2 is 4. And the root of 4 is 2. So when x is 6, y is supposed to be 2. If you consider when x is 4, 4 minus 2 is 2, and the square root of 2 is 1.4 something. The square root of 2, which is a third, is 1.414. So they are all along this particular line, and they are all along that particular line. So this one now happens to be y is equals to fx, which is also equals to the root of x minus 2. If we consider now the inverse function, you must consider its original domain. Its original domain is 0. When you consider its original domain being 0, and the very first range being 2, we can already substitute 0 in this particular function. And when x is 0, 0 squared plus 2 is simply a 2. I want you to look at this particular point and this point. They are kind of a reflection of each other along a certain mirror line. Don't forget the coordinates of this point are 2, 1, and you have 2, 0 rather, and we have seen the coordinates of this point is 0, 2. They have they have a serious relationship. When x is going to be a 1, because x can be a 1, so 1 squared being 1 plus 2, then we have a 3. Then when x is a 1, we have a 3. You can already see these coordinates is 3, 1, and this coordinate is 1, 3. So there's a lot of relationship. When x is probably, let's say, a 2 for that matter, 2 squared, which is 4, plus 2, which is a 6. 2, 6. And you can see now our graph resembles something like that. Again, if you consider this particular point, whose coordinate is 6, 1, and this point, whose coordinate 6, 2 rather, whose coordinate is 2, 6, then you can already see that it's all these points corresponding, this corresponding to this, this corresponding to this, this corresponding to this. And all those points are actually a reflection of each other along the mirror line y is equals to x. Because if you draw that line and call it y is equals to x, that you'll find that it's a reflection of each other. So this being the graph of y is equals to f prime x, or the inverse of x, which is given by x squared plus a 2, it is a reflection of each other. So in conclusion, this is enough proof that the function fx reflects along the line y is equals to x to give the function, the inverse function of x. So this is very important and critical for all of us to remember. The inverse function is a reflection of the original function along the middle line, y is equals to x. All right?